म्यूट करके रखो। दिख रहा है ना? यहाँ पे दिख नहीं रहा। हाँ, Can you hear me? So guys, we will start in 4 minutes. Just wait. We are waiting for the participants. ये बंद कर।
Good afternoon, everyone. It is 1500 hours. This is Angad Kulkarni, Director Wiprush Technologies Private Limited. Today, we are here for the free session arranged by Wiprush Technologies in association with Analog Brains Nagpur. Today's session is about Introduction to LabVIEW. It is my privilege to introduce you to our today's guest speaker, Mr. Atul Gumde. Mr. Atul Gumde is the founder of Analog Brains Nagpur. He has 9 years of industrial experience. He is a certified LabVIEW developer, having working experience with alliance partner of National Instruments. He has experience in the domains of biomedical, aerospace, semiconductor, automobile, energy, defense, and cement industry. He is a formal mentor of CDAC. Mr. Atul Gumde works in Python, Linux system programming, LabVIEW, embedded systems, and much more. I request Mr. Atul Gumde to please proceed with today's session. Thank you.
Thank you, Angad, for giving me opportunity to talk about G programming. I hope people will enjoy the session, and session will be definitely helpful for all. Okay, so let's start with session. Before starting, there's few requests I wanted to do. Please switch off your mic. Please switch off your phones and turn off your mic. And if you have a question, you can ask me on directly chat. There's no problem at all. So yes, as Angad introduced me, Atul Gumde, founder and solution architect of Analog Brains, and I'm handling all the technical stuff of Analog Brains, and I have 9 years of industrial experience, and I did work on these domains. So the today's contents that I'm going to discuss about is introduction of my company, what we do, introduction of LabVIEW, what actually how LabVIEW is actually helping me to develop systems, why company need LabVIEW, and we'll see few of the demos in different domains. I'm going to talk about the statistics of LabVIEW, how many countries, how many countries are using LabVIEW, and I'll talk about how to do certification in LabVIEW, and where the and what are the companies and what are the reputed companies who are using LabVIEW to develop their systems, and how this LabVIEW are helping them in their research stuff, right? So I hope you guys are ready. So Analog Brains and Wiprush Technologies, we are system integrators. We work on hardware development, we work on virtual instruments and hardware. We are into machine vision systems, like industrial image processing, you can call it as image processing, control and monitoring system. We are into data logging system, test and validation systems, industrial internet of things, and these are the domains which we have covered yet. So before talking about LabVIEW, I think we should see the tenure of programming, how this LabVIEW came into picture, and how this formed, right? So let's talk about the history of programming. For the more than 21 years, NI LabVIEW has been used by millions of engineers and scientists to develop sophisticated test, measurement, and control application. While LabVIEW provides a variety of features and tools ranging from interactive to configurable user-defined interfaces, it is differentiated by its graphical general purpose language known as G. G means a graphical programming language, along with an associated integrated compiler, a linker, and debugging tools. A brief history of pursuit of higher level programming. We're going to talk about it. To better understand the major value proposition of LabVIEW graphical programming, it is helpful to review some background on the first higher level programming language. At the dawn of the modern computer age in the mid 1950s, a small team at IBM decided to create a more practical alternative to programming the enormous IBM 704 mainframe, a supercomputer in its day. In low level assembly language, the most modern language available at the time, The result was Fortran, a more human readable programming language whose purpose was to speed up the development process. The engineering community was initially skeptical that this new method could outperform programs handcrafted in assembly, but soon it was shown that Fortran generated programs ran nearly as efficiently as those written in assembly language. At the same time, Fortran reduced the number of programming statements necessary in a program by a factor of 20, which is why it is often considered the first higher level programming language. Not surprisingly, Fortran quickly gained acceptance in the scientific community and remains influential. 50 years later, there are still important lessons in the anecdote. First, for more than 50 years, engineers have sought easier and faster way to solve problems through computer programming language. Second, the programming languages chosen by the engineer to translate their tasks have trended towards higher levels of abstraction. These lessons help explain the immense popularity and widespread adoption of G since its inception in 1986. G represents an extremely higher level programming language whose purpose is to increase the productivity of its users while executing at nearly the same speed as lower level language like Fortran, C and C++. Let's see what is LabVIEW and who developed LabVIEW, right? So LabVIEW has its own abbreviation. You can LabVIEW. The full form of LabVIEW is Laboratory for Virtual Instrument Engineering Workbench. So with the full form of LabVIEW, you will understand that LabVIEW is not a IT based tool. It is specifically made for the core industries like instrumentation, electronic engineer, mechanical engineer, chemical, all these domains, all these departments can use LabVIEW for their projects, right? So it is a software development environment. You can call it as the IDE, and it is language created by a National Instruments company in 80s. It is a graphical programming language. I'm going to talk about what is actually graphical. It is completely data flow based language, and it has a extremely amazing parallel processing capability naturally. So there's no need to write parallel processes. There's no need to write. No need to call any libraries. No need to call any APIs. You can naturally create the parallel processing capability or parallel processes LabVIEW very easily. I'll talk about how to create parallel processes. So, who invented LabVIEW? Sir Jeff Kodosky is the father of LabVIEW, and he thought of creating LabVIEW for macOS, and he created LabVIEW for macOS, and then they developed specially for military application. They realized that the tool is very beneficial for other domains too, and they made it available for the Linux platform, and now we are widely using into Windows based platform, right? So what is LabVIEW and what is graphical programming, that I'm going to talk about now. I hope you guys are aware about the Scratch programming. What is Scratch programming? Um, the initial level learning of any kind of programs. It's completely data flow based. There's no need to write any kind of syntaxes, right? I hope you are aware about Scratch. You can find it on, you can directly see it in the Google, or might be you are aware about MIT App Inventor. If most of the students, they don't know how to develop any kind of app, but MIT, Massachusetts Institute of Technology, had provided a very amazing tool that is called MIT App Inventor to create any kind of Android based application. So, and that is completely graphical based program. There's no need to write any kind of syntaxes. There's no need to write any kind of program, nothing, right? Just think a flow, or put it in a graphical way, and your application will be ready, as similar as that, right? So LabVIEW is, you can call it the same. So LabVIEW is different from most other general purpose programming languages in two major ways. First, G programming is performed by wiring together graphical icon on the diagram, which is then compiled directly to the machine code, so the computer processes can execute it easily. While represented graphically instead of the text, G contains the same programming concept found in the most traditional languages. For example, G includes all the standard constructs such as data types, loops, event handling, variable, recursion, object-oriented programming, queue, notifier, mutex, semaphore, all this thing is possible using this LabVIEW, or you can call it as a G programming. The second main differentiator in G code develops with LabVIEW executes according to the rule of the data flow instead of the more traditional procedural approach. In other words, a sequential series of commands to be carried out, found in most text-based programming languages like C and C++, data flow languages like G, as well as Agilent, VEE, Microsoft Visual Programming Language, Apple Quartz Composer, Scratch, MIT App Inventor, all this thing, right? So it promotes the data as the main concept behind any program. Data flow execution is data driven or data dependent. The flow of data between nodes in the program, not sequential line of text, determines the execution order. The distinction may seem minor at first, but the impact is extraordinary. But because it renders the data paths between part of the program to the developer's main focus. Nodes in LabVIEW program, in other words, function, structure, etc., as loops, subroutines, and so on, have input, process data, and produce output. Once once all of the given node input contains valid data, that node executes its logic, produce output data, and passes the data to the next node in the data flow path. A node that receives data from another node can execute only after the other node completes execution. That means you will find that in like C and C++ or in that text-based programming languages, it has the precedencies, operator precedencies. But in data flow based programming language, there is no precedency. Whenever data is ready, the node will execute it, right? So this is how the data flow based or graphical programming works. Let's see the benefits of G programming. So it's intuitive programming language. Like most people, engineers and scientists learn by seeing and processing images without any need of conscious contemplation. Many engineers and scientists can also be characterized as a visual thinkers, meaning that they are especially adept at using visual processing to organize information. In other words, they think best in pictures. This is the often reinforced in colleges and universities, where students are encouraged to model solution to problems as process diagrams. However, most general purpose programming languages require you to spend significant time learning the specific text based syntax associated with that language and then map the structure of the language to the problem being solved. Graphical programming with G provides a more intuitive experience. G code is typically easier for engineers and scientists to quickly understand because they are largely familiar with visualizing and even diagrammatically modeling process and tasks in terms of block diagram and flowchart, which also follow the rule of data flow. In addition, because data flow languages require you to base the structure of the program around the flow of data, you are encouraged to think in terms of problem you need to solve. For example, a typical G program might first acquire several channels of humidity data, temperature data, or light data, or mic or audio data, or picture data. Then it passes to the function where he need to analyze it, right, for analysis function. Then finally writes the analyzed data to the disk or to the internet server or to the IoT based platforms, right? Overall, the flow of data and step involved in the program are easy to understand within a LabVIEW program. It has an amazing interactive debugging tools because LabVIEW graphical C code is easy to comprehend. Common programming tasks like debugging become more intuitive as well. For example, LabVIEW provides unique debugging tool that you can use to watch as data indirectly moves from wires of the LabVIEW program and see the data values as they pass from one function to another along with the wires. And that amazing facility of LabVIEW is called as a or you can call it as a highlight execution, right? So let's see the graphical programming. What is actually graphical programming is, we won't talk more now. I'll directly show you how it looks like, right? So this is LabVIEW program, a simple LabVIEW program where I'm performing two different tasks. Where what I'm doing here, y is equal to number 1 plus number 2. You can call it as a process 1. This is the process 1, and result is equal to number 3 plus number 4 minus 100, and you can call it as a process 2. As if you don't know about LabVIEW, let me talk few of the important concepts of LabVIEW. Whenever you will open LabVIEW, whenever you want to write a program, that program will call it as a VI. You won't call it as a program. Whenever I will say this VI, that means this program, right? So in every LabVIEW program, there is front panel and there is block diagram. What is the use of front panel? Front panel is for user interaction, to get the input and to see the result. That is the use of front panel. And what is block diagram? If you want to write any kind of logic, you can write it there in this block diagram. So in very simplest term, front panel is a front end and block diagram is a back end, where you are going to write your logic, right? So let's see what I did here. Yeah, as you guys are aware about C language, C++, any other programming language, that program language has data types, structures like loop, for loop, while loop, if cases, switch cases, all these things, all the terminologies which you have been learning in C++ will be, or that all the things are available in this LabVIEW programming language, right? So this square or this rectangle is actually a while loop. Every while loop has a iterator, right? I hope you guys are aware about iterator. It has iterator, and every while loop will stop with a proper condition. So this is the condition, right? Each data type has its own color standard. Like this orange color is float, this green color is boolean, blue color is for numeric integer, right? Pink color is for string. Width, the importance of width of wire is also important. If the width is this, that means a single data is flowing from the wire. If the width is bit thick, that means there is some array flowing from the wire, right? So this is how you need to identify. It will come with practice, definitely. I'm just giving you a simple example or simple I'm just showing you a simple program here. Just see number 1 5 and this is number 2 here. I'll specify 200 here and 300 here. How to run this code? Just click on here and you will find this code is running inside this while loop. As I said, this is the while loop. It is continuously running. When it will stop, when I will click on the stop button, it will pass true data here and it will go to the stopping criteria or the conditional terminal. It will going to stop it, right? So here, first of all, see this, the execution. 5 plus 2 is 7. You can see this 7 is printing here. 7 is printed here, or we got the output as a 7. 200 plus 300 is 500 minus 100 is 400. You can see the logic is working as expected, right? So as I said, it is two different parallel loops, two different parallel processes. I'm going to show you it's working. It is actually a parallel process or not. So we have talked about the concept called highlight execution. If you want to debug the code, how you can debug it in LabVIEW, just click on this parallel execution and you will find how data is flowing from the wire. I'm going to change it in runtime. See, I have changed it to 9 and you will find the 9 is flowing from this numeric 1, and now the data is changed. 9 plus 2 is 11. I'll change something here. You will find that 206 is flowing from the wire and the data is changed, right? So this is how you can debug the code, and you can see these two different processes is running independently. You might ask me, sir, we are not understanding it's running independently or not. So what I'll do, I'll stop the first process. I'm stopping this first process. Now you can see true is passing from this conditional terminal and first loop is stopped. It's not running, but second loop is still running. That means it is parallel process. It is not stopped. This code is not stopped because I haven't stopped the second process. Let me stop the second process and you will find the second process is also stopped, right? So this is how you can create your own simple logics easily in LabVIEW just by using nodes. So when I said nodes, I haven't talked about how to call these nodes and how you can find all the functions. So if you want if you want front panel element, just right click on the front panel element and you will find all the front panel elements are available inside the control palette. You can use this boolean, you can see this thermometer kind of thing here. So you can create your own supervisory control, right? You can create your own SCADA, you can create your own GUI, you can see this meter and all, right? So these are all controls and indicators. If you want to find how to how to create logic, just right click on the block diagram and you will find the function palette. You can find the function palette and you can see this add, subtract, multiply, all the logic based functions will be that is available here in the function palette whenever you will right click on the block diagram. So this is the very basic concept of LabVIEW. There are so many things you can explore it. A good news for you guys is if you want to download LabVIEW, I'll definitely going to share a link here in the description of YouTube channel, and you can directly download LabVIEW for evaluation. LabVIEW is available. You can evaluate. You can learn LabVIEW very easily. And there is a community edition. Just in prior 2-3 months, National Instrument actually launched it. You can try the community edition also. So let's see a few of the amazing examples. I'm going to talk about few machine vision demos. I'm going to talk about how mechanical engineers can use LabVIEW, how electrical engineers can use LabVIEW. So let's see my favorite example, PCB inspection. I'm running this code and you will find how you can inspect PCB. So this is the demo. You can create your own what you can say situation, or it's like a camera is there, illumination is there, and then you can put a PCB inside the camera, or I mean nearer to camera, and that camera will capture the PCB photo, and you can do inspection or you can do analysis whether all the components are placed properly or not. If there is not, if the solder is not properly, or if few components are missing, you can directly capture it in this image processing based tool, where you can create, or you can create logic in very easiest way. I'll show you the program. This is the program of PCB inspection code, right? So this is the while loop. You can see error handling. You can see there are IMEC based functions which is specially made for the image processing algorithms, right? These are the APIs. So this is the image processing based or machine vision PCB inspection system, right? So let me stop this VI. Let's see. This is called as a Poka-Yoke system. If you want to launch or if you want to what you can say, if you want to check your quality of your product, you can create in this way by using machine vision based system. So consider there is a company who is actually manufacturing lights, and you want to test the intensity of light. So how we can test it? So this is how the system can be used. You can create your own system where you can find the intensity check. You can check the intensity of light by using this kind of algorithm. Let's see the code. You can see the code is very simple, right? Very simplest code. So this is how you can create the algorithm to check the intensity of light. Of course, these are the simulations, but you can actually grab the image by using camera, industrial camera, smart cameras, and you can do processes using LabVIEW. This is one more. Let's see the example of PVC manufacturing company. Consider a company is manufacturing PVC, and they want to check the defects of PVC pipe, cross-sectional defects. How you can check it using machine vision tool of LabVIEW. Right. So this is the first image, and you can see it has defect here. See, you can check defect very easily. Right. So this is the PVC defect mapping system, PVC pipes, sorry. So this is how you can create code. You can see the code of LabVIEW, right? Let's see, consider we want to create a project for agriculture in agriculture domain, right? I want to count potatoes, how many potatoes are there by using machine vision. So this is the best way to count the potatoes. So these many potatoes are here. These red marks is the analysis done by LabVIEW. You can see we can do morphological reconstruction, isolated particles, that is like a blob analysis, and then we can calculate how many potatoes are here, right? So this is how you can count the fruits or the objects very easily. Let's see optical character recognition based application, very booming concept. So this is optical OCR based application. Let's see the code. So you can create data sets very easily uh, to compare with the image, right? So this is OCR based application. Let's see object tracking algorithm, how object tracking algorithm works. So this is the program where we are tracking a car, right? We are tracking a van. I hope you guys can see this. So with the help of this algorithm, we can create create this kind of application also, right? Optical flow tracking. If you want to track the optics, see this is a optical flow tracking based system. These are all examples. If you will download LabVIEW, you can directly find it in example of LabVIEW. So this is how we can create so many machine vision based algorithms. So this is like object classification. Here my algorithm is saying this is motor, this is washer, this is worm gear, this is bolt, this is worm gear 2, this is motor, this is bracket, this is gear screw. So this algorithm LabVIEW is finding out that is giving classification whether what this um, object is, what I mean, it's motor or bolt or something like that, right? So you can create this kind of logic also. So it was all machine vision based. Let's see some mechanical domain examples. Let's see this. Consider you want to find the you want to do a partial differential, you want to write a partial differential equation for the string vibration. If you want to find how string will going to give vibrations, so you can use this uh, PDE system to calculate a one-dimensional wave of string, right? So this is one way. I'll talk about how you can do PID tuning. So this is PID tuning based algorithm. You can set up your own PID logic, and you can connect with some kind of system, and you can stabilize your system by using simplest by using this kind of algorithm, right? I'll give you best example of PID. uh, Fuzzy based SCADA. Yes. So consider there are two tanks. There are two different tanks, and you want to control the level of the tank, right? And you want to maintain the pressure, flow rate. So you can set up a fuzzy based logic, and you can control the flow rates, right? So you can create your own SCADA based system. And if you find the logic, you can write your own code, a C code. You can use this fuzzy controller Then you can, of course, you can create arrays, loops, all these things are available, and whatever you have been learning in your curriculum, you can directly try it in LabVIEW. These are all available in the examples of LabVIEW installer. So whenever you will install it, you will get all these example, and you can see how how the code is written in the LabVIEW. Let's see this PD thermal distribution, how single plane thermal distribution happens. You can simulate the data, and you can create system like as per the simulation, right, as per your observation, right? So tank level controller, let's see how. Okay, just temperature monitoring. Okay, PD thermal distribution. Yeah, a very interesting car backward parking system. Wait a minute, I think I have to start LabVIEW 2020. Okay, so let it be. I mean, there, if you will install it, you will going to find all these example car backward parking system using fuzzy, how automatically car will decide how to park it. You will find all these example directly in LabVIEW. So guys, let's install LabVIEW in your system and try to find it out these examples, and try to find how this code works, right? So let's talk about more where LabVIEW can be used for. You can use LabVIEW in the automated test bench system, data acquisition. You can use it in SCADA, PLC control, FPGA programming, instrument control and monitoring, signal processing, embedded system design, and still counting. You can use LabVIEW anywhere, right? So let's see the statistics. How many companies are using LabVIEW? I'm going to talk about few of the real statistics. This is the link where this link is very active, and you'll understand how many companies, how many countries are using LabVIEW. So you will find there are 16,743 companies who are using LabVIEW all over the world, and first is United States. 8,597 companies are there who are using LabVIEW, and India is in second rank. So India, if you are Indians, it's a good opportunity, and if you want to go outside, if you want to do work outside India, it's a really very good opportunity for you guys, right? So this is the statistics, and of course the statistics will definitely open your eyes, and you will going to learn LabVIEW, and of course, if you if you are thinking that you want to go, if you don't like programming, if you don't like C language, if you don't like this kind of thing, but because you love your core industry, so LabVIEW is definitely best for you guys, right? So this was the statistics. So what more you can do using LabVIEW? From LED blinking to building spacecraft, you can do anything and everything using LabVIEW, right? How many companies are there who are using LabVIEW? NASA, Tesla, John Deere, Texas Instrument, Philips Analog Devices, Honeywell, Amazon, Tektronix, Eaton, Siemens, General Electrical, MIT, Massachusetts Institute of Technology, General Dynamics, and so many, right? So many biomedical industries are also using LabVIEW to develop their own system. You may have seen so many GUIs, but you don't know it is designed in LabVIEW or not. But yes, there are so many industries who are using so many industries who they are using LabVIEW for their image processing. They are using LabVIEW for their signal conditioning. So so let's see the certification levels of the LabVIEW. If you want to be a LabVIEW developer, of course, first of all, you need to install it. There is a very important, and the primary step is first go to labview.com, ni.com, go to downloads, download LabVIEW, start learning LabVIEW in evaluation period, or just download community edition, start learning. This is the very first and important step. It will take if you can learn things very easily, so in within 2 or 3 months you can give the exam called Certified LabVIEW Associate Developer, CLAD. It's a very basic certification level. If you clear CLA, that means you know LabVIEW, you are aware about LabVIEW. Then there is the intermediate certification level, that is certified LabVIEW developer. That means you are pretty aware about LabVIEW, and you can do programming, you can write very good applications if you are CLD. The third very I mean, it's a higher level certification is like expert level certification. It's certified LabVIEW architect. That means you can write architectures, you can do object oriented programming, you can do so many things using LabVIEW. That is CLA, right? It is 3 years. Sorry, just 3 hours exam. Minimum 70 marks is passing, right? If you are interested in embedded system and LabVIEW both, you can give this exam called CLED, Certified LabVIEW Embedded System Developer, right? If you are CLD CLA, that means you are internationally eligible for LabVIEW based projects or companies, right? Most of the companies are always looking for CLD and CLAs, and you will definitely get good wages here. You can directly check on Google that how CLD and CL, what is the pay scale of CLD and CLA, and you will be fascinated, and you will definitely attracted to the salary structure also, right? So why you should learn LabVIEW, and why companies are giving good wages if you are learning LabVIEW or if you're into LabVIEW. So let's talk about other programming languages. All projects is like completely based on time and money, right? The time you will spend, that means you are spending money with respect to time, right? So consider there are 8 different tasks in a project, and you have decided time, or you have decided a money here, right? So if you are taking if you are taking this much of time to complete task 1 and task 2, task 3, you are taking so much of time to complete a project. That means you are left with this amount of profit, right? But because there are so many companies, or in regulated industry, you will need to create evidences for all kind of project. Like if you are completing task 1, you need to create evidence it's working fine or not. You need to do unit test, you need to check it very well, unless and until the task 1 module is completed well or not, right? You cannot move ahead unless and until you will complete task 1, or you will create evidence, right? Because the evidence will help you to create the documentation for the project, right? So what is happening, you need to create all type of modules, right? You have to think about syntaxes, you have to think about semicolons, you have to think about where I have written this line and all this stuff, right? But in LabVIEW, if you are using LabVIEW, there is possibility that you are completing so many tasks in one time, because most of the modules are already ready, right? And it is already approved, it is already designed, and it is already tested. So no need to think about what will be the syntaxes, what will be where will be the semicolons, where I have written these lines or not. If you are facing some problem, of course the debugging tool, interactive debugging tool, can help you to find out the problems, right? So this is how LabVIEW will help you to complete the project in very less time. That means you are left with ample of time, and you can earn this much of profit. Actually, you can start your project too, right? So this is how you can the companies are earning profit, right? That's why companies are ready to pay you very good wages. So what we have did, we are not from training background, we are completely industrial guys, right? We have decided in this COVID pandemic that we will spread and grow you guys. We will provide knowledge whatever we have been learning in our industries. We should talk about what we are learning, how we are learning, and how to think about any kind of project. So we have started few of the training sessions, like foundation training, CLD training, training plus internship, right? So these four things are available with us, and if you are interested, if you want to enroll for any kind of, I mean, training and internship is like very this is our very currently it's booming. We have already did three four batches, and most of the students are placed in good companies, and most of the students have completed their CLADs, right? So guys, if you are interested, definitely you can join our training plus internship program. And of course, scarcity of skilled and certified library developer is the opportunity to get dream job in core industry. And due to this pandemic in India, there's chances of automation companies, they will definitely come and they will look for the skill developers or skill automation companies or the skill automation resources. So definitely you should not dig down the well if you are when you are thirsty. It's better you should prepare for the situation, right? So guys, you should definitely learn LabVIEW for if you want to join core industry. So guys, thank you so much. I hope you love the uh, session. If you have any kind of question, if you have any doubt, you can directly mail me. This is my mail ID, atulghumre@analogbrains.com. It's my number 9860013298. You can directly WhatsApp me. If you want to join our LabVIEW group, you can join it. You can send request uh, directly on this mail, or comment you can comment your numbers in YouTube comment section, chat section. And you if you have any question, you can comment me in the chat section. I will definitely love to help you guys. Thank you so much, and I hope you have enjoyed.